So Friday we talked about drawing vectors and how we had to add them. Section 2. Oh, chapter 3, yes. How we have to add vectors head to tail, make sure that they aren't going head to head, and so you would add head to tail and then draw a resultant in there, and how to solve them for the resultant graphically. This section is over using mathematical functions like our trig functions and the Pythagorean theorem to solve for resultants.
Yes. Kept frustrating me. These aren't trig problems. I guessed it right
We are
one
just
time, so
learning
now I'm
basic
good.
Chapter, what are we doing? What chapter?
3. 3.
Oh,
So we will use a traditional XY coordinate system. Basically, we're going to draw them at the correct angles. No. What is bearings, I should say?
7 degrees plus.
We'll do like 30 degrees east of north. Is that bearings? Yeah.
It's like from north 30 degrees to the east.
Yeah.
Question on
That's
the final
bearings.
quiz. It's like that.
Okay.
And then we get factored wind with it.
What?
Do we get factored wind with it?
That's
Yeah.
like vectors and stuff, and I hate
That's
that.
awesome, like a plane with
I
having
guessed it,
wind.
I got it right, now I can get it right.
Okay, so Pythagorean theorem and the tangent function is all we'll need to add vectors together. It's more accurate and less time-consuming than the graphical method. So we will be using our trig functions.
I didn't even get the
Everyone knows the Pythagorean theorem, right?
No! C squared equals A squared has B squared.
No.
Yes.
Plus B squared equals C squared.
Sure.
Technically, but not really.
But remember that C is the hypotenuse, and then the A and B are the length of the legs.
Close, so I have to get up.
Chase, sit.
No, somebody close the door. What if somebody comes in?
I'll go get it then.
Okay.
Yep, we'll be okay.
Wait,
Everyone knows the trig function SOHCAHTOA?
No.
Uh-oh.
Sine is opposite.
I don't know.
Hypotenuse.
Sine is
Adjacent over opposite.
adjacent over hypotenuse.
Opposite over adjacent.
All students
Yes.
take calculus.
Yes.
However you guys
All of them are positive, and then
remember them. Remember,
tangent. No, it's students. All take students. No, it's cosecant are positive. The third is.
this is all we need, okay? You would only have to know SOHCAHTOA.
We only have to know those?
Yep.
Yes.
You should be able to solve everything without.
Cosecant and
Nope.
sine and
Nope.
cotangent.
Nope.
It's funny because
Okay.
pretty awesome.
Let's see.
Okay, let's think about who likes trig. That's right. So
Okay, 12 kilometers east plus 9 kilometers east. We would get a resultant of 21 kilometers east. That's pretty simple.
love this.
If you have 12 kilometers east and 9 kilometers west, your resultant is 3 kilometers east.
Pretty basic.
That's pretty basic. Now we're going to get to angles.
Yeah, angles. The head can't touch the head, and the leg can't touch the leg.
Yes. So if we have 12 kilometers east and 9 kilometers south, our resultant is going to be 15 kilometers at 37 degrees south of east. Let's write this out. We have 12.
Square root that.
Yeah, 144 plus 81. Yeah, we all know that's 225.
So how would we solve for this? If this, you can't really see it, but how would you solve for the hypotenuse? Yes, so what is it? 9 squared plus 12 squared equals c squared. So c must be equal to 15. Ha-
Why can't it be 15?
When you solve that?
9 squared plus 12 squared is 225.
Okay, now we need an exact angle also. How would we find the angle? We want this angle. Right, tangent. So tangent of theta is equal to opposite over adjacent, 9 over 12. We need this angle. We need this angle. Because we don't know the hypotenuse.
Well, we can find that really easy by. Yeah, but.
Well, we could use, okay, so we could use 15 and use sine or cosine. Shh. Chase, Derek. If you use 15 here, then and use sine or cosine, then you're not quite as exact. You want to use all the numbers that they give you. That will give you a better answer. Not always. Depends on what numbers they give you.
If you can, always use what they give you.
Yes. Use what they give you. Use what the problem gives you, so that you don't have any rounding going on in your numbers. We will get to that. And so this must equal 37, because that's what they give us here. Now, south of east. Why south of east?
Because it's east and south. Boom.
Right. This angle is south of the east direction.
That's like bearings.
Yeah.
What's 15 kilometers again?
That would be the hypotenuse. So this was 15. Yes. We found it. But we don't want to use it in our calculation of the angle, because that's not, unless you get 15 exactly. I don't know what you get for C exactly. Do you get 15 exactly?
Yeah, but then it doesn't matter. But if you messed up and like you were supposed to get 15 and you got 13 and you used 13 and you get 2
Right.
wrong.
Yes, correct, Tyler.
Technically, you could get like resultant square root of 34 at whatever this, right?
I want actual numbers, decimal numbers. Don't leave the square root in it.
Why?
Or don't leave the fraction in it.
Yeah.
Yeah.
Square root. That's why I have a Casio. Use it as square root.
Okay, this time we're going north. Why did it change it to 8? I don't know.
We're going northeast.
So this time we're going to do the same thing. We would use the Pythagorean theorem. We'd have, this is 12 kilometers. This is 8 kilometers. And so then when we use the Pythagorean theorem, we must get 14.
We get what? 65.
Y to the right, here,
Yeah.
this arrow? Because east is to the right.
208. Okay. Which is not 14 squared. What's 14 squared?
What angle equals 60?
And now we need to find this angle. So this is the north of east angle. Now, whenever you have an angle north of east, which I should go back and explain the other one too, but whenever you have north of east, I don't care if you put north of east. If you put just 34 degrees, that's going to be assumed it's this north of east. Because we're going to assume that we have quadrants, and whenever you measure the angles, it's always here.
Wouldn't it be like quadrants, then you have to have negative numbers?
Depends. Okay, so let's go back to that last one. For this angle, what was that angle? 37?
Yeah, 37.
We could give, if you want instead, you could start here, give this whole angle all the way to here, or it could be negative 37. That would be fine.
Say that. I understand. Say it proud.
I prefer 37 degrees south of east, because that's the number that you calculate. You'll calculate 37, and you won't have to do any other
How about
I think like negatives for the side.
for the sides.
Like if you're going either way.
how about just negative
Like if you're in the
127?
left side, like of the y-axis. What is it supposed to be?
The west side.
Like if you go
No, this
west-
is always like you start from the origin.
Yeah, if you start from origin and go west,
Then you'd have an arrow pointing to the left.
but it's positive numbers still.
Yeah, it's still a positive number.
So it's not
Your arrow is showing the direction. You don't have to put a negative to show the direction.
Cartesian plane numbers.
Okay.
You know, maybe x is negative 1.
Oh, right. No, you don't have to use negative x, whatever. Yeah. Remington, you have a question?
Like 3, could you put 127 from north?
Is that what, when you take 360 minus 37?
Why would you do 360 minus? Because bearings go clockwise. What is this? This isn't bearings. But I want it to be.
Remington, you can't always get what you want.
But if you try
Right.
sometimes,
What?
if you try sometimes.
No, no.
Okay, now if we are giving if we're given a vector, a single vector, and you need to break it into its components, what we're talking about is finding the horizontal and vertical component, meaning finding the x and y. So you're going to be given an angle. You'd be given this. So that, let's say you have one vector. Here's your vector, and it wants the x and y component. You're going to split it up into, this is the x, and here's the y. This would be the x, and this would be the y. And this is where you'll probably use sine and cosine, because they would have to give you the value of the hypotenuse, and they would give you an angle. Do you call it sine and cosine in German, and in French, do you call it, or what is the name of those, the trig functions? You would think.
You never had trig?
It's the same.
You've never done the angles? Okay. It's the same. Okay.
Oh, my pen broke.
We'll have to kind of go over this then. Okay. We'll probably want to go over that using the trig functions. Oh, you're in trig? Have you done any of them yet? Okay. So you've only done it in English. You haven't done it in German. Okay.
How'd you get 100 on that trig test? How'd you get 100 on that trig test?
Ow. So resolving vectors into their components is opposite of vector addition. You're basically finding the two vectors that will add together to give you your resultant. For the vectors shown at right, find the vector components x and y. Okay, well, let's find Vx.
There's x. I found it right there. What's option?
You want to use cosine.
For finding the x, this would be the adjacent, so you would want to use the cosine of what?
20.
20 is equal to
X over 95.
Vx over,
Times by 95 cosine 20.
so Vx is 95 kilometers per hour
Okay, why are we talking
times,
Multiply both sides.
Because?
so Vx is, let's make sure we get the right answer, 89.27. So in significant figures, since we only have two numbers here, that's why they answer in two numbers.
Wait, significant figure is why. Let's do this one. 1 or 6 tenths.
So we only have two, oh, right here, two here. So our answer would only have two.
But that's 89.27.
Well, but in correct significant figures, this would be your answer.
You just dropped it.
Yeah.
And the 7.
Now let's see if we find Vx. What trig function do we need to find Vx or Vy? If we want to find Vy, we're using the opposite sine of 20 will equal Vy over 95. So Vy is equal to what'd you get? 32.5.
33 rounded up. 32.491.
Yeah.
Round
Yeah.
5 up.
If I got an 85.49 on my test, it would be an 85, right?
Whoops.
What?
Boom. See, blows mine.
32.49.
Round.
So it would round to 32.
Yeah, that goes to 32, Brad.
Oh, the mighty Casio has fallen.
Is that what they got? Let's see if we're right.
9 rounds, 4 to 5.
Yep. 32 kilometers per hour.
Yeah, that sounds right. Yes.
You don't do two rounding. You just round once.
But you round the 9s with a
No.
Yes.
No. No.
It makes sense. It's like when you drive past something and it looks like it's standing still.
Is
Because
drive by something,
Yeah.
it's moving that way, the same rate you moving that way. Is that right? When you're in that stinking school bus problem, when I'm driving, it's quarter one with. If I'm on the bus going east and there's a dude standing still, he's moving west the same speed I'm moving east.
Yes.
Boom!
Whoa. Jack.
The 0 makes the 9 stay.
Sam doesn't know his life
closer to 0. But the 9 rounds to 4 up.
What if it's .491 repeated?
The 1 bumps the 9.
Is that
9
zero?
bumps the 4.
Oh, Myers just shuns you. Oh,
And 9 makes the
Okay, so now if we have non-perpendicular vectors, we have to do multiple steps. We have to resolve each vector into x and y components. So this is D1. You would have an x and a y component for this triangle or for this vector. And then you would have a x and a y vector for this vector, x and a y component. And what we do is take the two x's, add them together, make a new triangle, adding their x's and y's together. And now you would find the resultant of this new triangle, and that would be your resultant. You would add them. It's really pretty simple. So D1, you would have, let's just draw it. Let's say we have, whoops, that's not straight at all. Okay, so this is D1. We would want to find, this would be, we'd call it X1, and we would find Y1. Okay? And now, let's say this is D2. They aren't at the same angle. So now here's D2, but we're adding these two together. So when we add them together, we get this resultant, but we can't solve for it using our cosine and sine and stuff. So now we'd have, that's not straight at all, I know. We'd have a new x here too and a y here. Now what we would do is we'd have x1 plus x2, because they're both in the same direction. If they were in opposite directions, you would subtract them.
But I don't understand if it's not a triangle, how are you using cosine and sine at all?
We're making a new triangle. So now we have y1 and y2. What? So now we'd have, oh, let me change it to blue. Blue, red. Red might show up better. So here would be,
Meyer, just explain to me. Just treat me like I'm 5.
Over here.
Yeah, it finishes it. But when you put them together, they're not
so here's x1,
doing that, right?
here's y1. Okay? And now this would be x2, and this is y2.
Two triangles and then a rectangle.
Yeah. I want 2 triangles. That's all I want.
We just have 2 triangles, yes.
So that big one.
Ignore that. That would be not drawn. Yes. So now we take x1 and add it to x2, and take y1 and add it to y2, and that's where we would get this new triangle. Let me use green. This would be the new triangle now, after you add them. Yes, it will be.
How does that work?
I understand that, but what are we trying to find?
We're trying to find the resultant between D1 and D2. When we add D1 and D2, we need to find this dotted line. We need to find the distance there. You can't do that using just these 2 lines because they're not right angles. You don't have anything to calculate it. So we need to make 2 new triangles, add them together, make a new triangle, and find that resultant.
Because D1 plus D2 is longer than D.
No, the resultant. The resultant. We need to find the resist. Okay.
The resultant is this.
Right, okay.
Resultant is another word for
Displacement. Yes, the resultant would be like displacement. Okay. Does that make that perfectly clear? Okay.
He was trying to get
Do we want to watch the visual concept?
Yeah, Ram. Miss Cleaver, Remington just found that in my
What did I do?
Put your foot over under your desk and you wouldn't be able to reach it.
Jacob's throwing stuff at me, Miss Cleaver.
Yeah, see, Bunny knows.
Jacob's
his
has
foot.
Jacob's pretending to get high off this little.
Any two vectors can be added algebraically by simply finding and then adding their x and y components.
Whoa, I have to push next.
Find the x and y components of each, as we have done before. The total vector can be found by adding the components. The total x component will be the sum of the x components. The total y component will be the sum of the y components. The result will be the x component and y component of the resultant vector d.
Oh, hell yeah, hang on, I blinked and I missed that.
Find the x and y
Here, watch,
components of
watch.
each, as we have done before.
Watch it again?
The total vector can be found by adding the components. The total x component will be the sum of the x components. The total y component
is the
will be the
same.
sum of the y components. The result will be the x component and y component of the resultant vector d.
D1 and D2 if you're taking those out?
You'd ignore them. After you get the x and y from it, you don't really need them anymore.
Well, why can't we just find the X and Y of both of them and add them?
That's what we're
Are we
doing.
gonna do homework with like problems like this?
Yeah.
Do we have to like show our work with like making the two small triangles?
The
Yes.
magnitude of the resultant can be found using the Pythagorean theorem.
Track them together.
The direction can be found using the tangent function. Since the tangent of an angle is equal to the opposite over the adjacent side, you can write this. You can then find the direction of the resultant vector with the arctangent or inverse tangent.
What else does he say?
We now know the exact magnitude and direction of the sum of our two original vectors.
Very good. That's it. Okay, a camper walks 40. Yep, let's do this problem. Camper walks 45 kilometers at 45 due or north of east, and then walks 45 kilometers due south. So that looks like 45
No, the Friday challenge.
or 4.5.
So the whole vector is void, right? Ohio State, like that's just the answer.
That's what I've been saying.
Who knows the Friday challenge?
All I know is my shoe got untied and Remington did it. I want to know why.
He likes to.
How would we find this?
Does that stop the vector?
First, you have to complete the triangle. So
Yeah.
No, because let's find. Oops, let's go back.
See, I told you I needed to open that door. Let's get your tongue back. Yeah, let's get your tongue back.
It's Miss Cleaver.
Do you need anything?
Yeah, I need to come to class.
Oh, where have you been?
I was in college bio. And then I went to the restroom, and now I'm here. You just recorded all of that.
I took your shirt off. Thanks, Ram. Now redo it.
You know what?
Now, would the y component be 4.5 if the hypotenuse is 4.5? Yeah, this is not to scale. So this 4.5,
Yeah,
it's going to be longer, isn't it? No.
It's a 60-60-60 triangle, so it's 4.5. How is it not? If you go 4.5 one direction, 4.5 the other direction.
Let's find our x and y components of the 4.5. Let me erase this.
45 pretty much. You know what I'm saying?
Draw the picture like to scale. I'll try. It's going to be more like this. Right? Isn't that what it's going to be more like?
Yeah, that's more. So give me another 4.5 for the other side.
So is this a right angle? Is there a right angle here? No. So we need to find the x and y components of this triangle. So we need this x and we need the y here.
I don't understand this. Why can't you go 4.5 the other way?
4.5 this way? Because if I make a 4.5, 4.5 triangle, the hypotenuse is not going to be 4.5.
How do you know that angle's 45?
Hypotenuse has longer than 4.5.
So, how do you know to draw? Like,
I don't know what angle that is. Like, yeah.
how do you draw?
Maybe-
Okay, here's north and here is east. And if you cut it in half, that's a 45.
Isn't this going to be 45 right here?
That's 45, and then you go directly south. So then that should be 45 there. That's 45 degrees.
They give you 60. Yeah.
I don't want a 45 degree angle. I want a 60 degree angle.
Okay, what is x? X, we would use sine, cosine, or tangent. Cosine of 45 would equal, it's a 45 degree angle. What is x? 3?
Is that 4.5?
Just 3? We'll go 3.1.
So, why do you draw the? What is north?
This means that we're going northeast, yes. Yes. So y is equal to 4.5 times the sine 45. No. That's only of this triangle. This 4.5 is a separate distance, separate. So what we want to do is add our x's together and our y's together. There's only one x though, right? This is in only the y direction. We don't have an x portion to this 4.5. We only have an x portion to this 4.5. So we would have a new triangle of so the resultant would be, here would be the resultant. This is what we're trying to find right here.
I get a syntax thing here. Try to do this. What are you trying to do?
So here's our x is 3.2 kilometers. Now, this 4.5 is down, but the y is up, right?
What?
4.5 is south, but this y vector or y component for this 4.5 is north. So you need to take the difference of them. What is the difference? 4.5 minus 32.
Why is it? What's 32?
3.2, sorry. 4.5 minus 3.2 is what?
Is 1.3.
1.3.
So is that 1.3 on the bottom triangle then?
Basically, this little portion right here, from here to here, is 1.3. Yep. So we have, and that's downward. So we'd have here. So our resultant is right here. We need to find, that's what we need to do. We need to find this.
R is what we want.
Right. So what is R? 3.4?
No. You go 3.5.
It'd be the square root of 3.2 squared plus 1.3 squared. 3.4 or 3.5?
Well, sig fig, so 3.4.
Okay.
Is that 3.2 squared plus 1.3 squared?
Yes.
3.5. It's 3.5.
No, we already had this discussion, Sam. Apparently math doesn't.
What is it really? 3.4 what?
So it should
3.45.
be
So it's 3.5.
No, Remington thinks that when you round, that you
No,
that
we just had this discussion. It was supposed to be 3.4 according to you.
No. You don't round it twice.
You don't.
You just did.
No.
Remington, aren't you in calculus? Do you not understand the fundamentals of math?
Okay, this is our magnitude. Now we need to know direction.
Oh God!
So we need to know this angle. We need to know theta.
Fractions are a division that's not done yet. Decimals is fine.
Opposite over hypotenuse. So 1.3 over 3.2.
No, decimals are.
Where? Decimals are fractions are
Yes, exactly. So decimals, fractions are lazy.
Yeah, well, decimals, you have to end up around.
Oh, it's just going to be south of east. 22?
That's a rounded decimal. That's different than decimal.
So we need an. Here's our direction.
Wait, how'd you get that?
And
I got .007. Yeah.
did you take the inverse tangent?
I don't know what you're talking about.
To get it over here, you'd have to do theta would equal the inverse tangent.
Why do you have to do the inverse?
That's how you do it. That's how you solve.
That's just how you do it.
Where did Keller go?
Because he hasn't been as gone as fast as me.
I wish I could be Keller.
You get from your library. I already have.
So your answer should have both magnitude and direction. You would need both. Does that make sense?
So that's the answer.
22.1, so 22. Yep.
So that would be the answer.
Yep. 3.5 kilometers, 22 degrees south of east.
But if it's asking for displacement, that's the problem.
Oh, it's displacement.
Displacement has direction too, doesn't it?
Yeah, it's
Displacement's the vector. Okay. There we go. 3.4.
It's just 3.4.
Yeah, it does. I don't know what the actual number was.
It was 3.45. I didn't actually solve it. I just thought you put the answer up there accidentally.
Let's look at your tests and we will start here
Oh, what the?
tomorrow. Tomorrow?